Hi guys, this is Mark from Education, and today we have an expert exercise about iterators. If you're not familiar with iterators, I highly recommend watching the video I linked in the video description. He explains things very well. The difficulty today is 4 out of 5, so if you consider yourself an expert Python programmer, this shouldn't be a problem for you. And as an expert, you should also be familiar with the object-oriented programming, which is required for this exercise. So, what is the task? The task is to write a class named binary encoder iterator that transforms binary values like yes or no, male, female, something like this to zeros and ones. So here, for example, we have yes, no, no, and we want to transform it to 1, 0, 0 or 0, 1, 1. To test your iterator, you have to write a small function that takes a pandas data frame and a column as parameters, and that uses your iterator to transform the specified column. And you're not allowed to use any other pandas methods. So pause the video if you want to try it yourself, and next we're going to talk about the solution. Okay, so recall that an iterator needs the iter and the next method. Let's write them here so that we have a nice skeleton to work with. Start with the iter method, which takes self as parameter, and the next method, which takes also self as parameter. Then we need a constructor, so let's write init, and we don't need this. And if we go through the task description again, we can see that we have to encode a binary and that we have to encode a given sequence. So what we need to pass to our constructor is something like this. We can call it sequence, for example. And then we say self.sequence equals sequence. And when we build iterators, we need a variable to keep track of where we are in the sequence right now. So we can call this index, for example, and I will initialize it with 0. Next, we have to make sure that the sequence contains at most 2 distinguishable categories. And one of my favorite things about Python is that we can use the properties of sets to ensure this. Okay, so if we have a sequence, or for example, a list with a given length, we can convert it to a set and then check the length of the set to see how many unique elements are in the list. Okay, and we can say we can use this here by saying check the length of the set of our sequence, and if this length is greater than 2, we need to raise an exception. And we can call, or we can say something like sequence provided has more than 2 different categories, something like this. So for example, if we have yes and no, this will work perfectly fine. But for example, if we have something like yes, no, and maybe, we will have 3 unique categories in this sequence, and this will raise the exception we wrote here. Okay, I hope this is clear. Next thing we're gonna do is distinguish between the 2 unique categories. Okay, so we need to say something like self.positive label equals, and then we can say list of a set of the sequence we provided, and then the very first element is our positive label. So for example, yes, in this case here, will be the positive label, where positive or negative doesn't mean anything, so we can also change it if we want. And then we also need a negative label. You might have guessed it, this is index 1. If you pay close attention to this code, you will see that this contains a small bug. Okay, this is not the perfect way to solve it. If you know the properties of sets, you might see the bug already. Okay, but I will leave it as an additional task and we will talk about it in the end. For the moment, let's keep it like this. Next, we're going to implement the iter function, and in Corey's video, you should have seen that this is fairly simple because we only need to return the instance itself. So return self, and we're done with iter method. Pretty easy. The interesting part is the next method. Let's start with saying if self.index is smaller than the length of our sequence? And if so, so this means, are we still inside our sequence? And if so, we can say our default label is 1, and only if the element we have at the moment, so sequence at the index self.index is equal to our positive label, then we need to change our label to 0, for example. We can also change this, so we can say 0 and 1. This actually doesn't really matter. And then we need to increase our index so that we don't stay at the same element all the time. And all we need to do then is return our label. Okay? So what happens here? Again, first we need to check if we're still inside our sequence. So if the index, our current index, is still inside our sequence. And if not, and this is what I'm gonna write here, we need to raise our stop iteration exception. But if we are inside our sequence, we say, okay, our default label is 0, and we override our default label by the other label, so 1 in this case, if the current element is equal to our positive label, which we defined in our constructor here. Okay, all we need to do then is increase the index and return our label. And that's it. We have a iter method, we have a next method, and we have the constructor. So this is a full iterator. All we have to do now is to implement the binary transform function to check if our iterator works. So we have the binary transformer function here, and data frame and column is given by the task description, where it says taking a pandas data frame and a specified column. And inside the function we say for element in, and now we use our binary encoder iterator, where we pass the data frame or the column of the data frame. When we have a look at the example here, we want to change the column yes, no, no, yes, so the answer column to 1, 0, 0, 1, 0, and so on, or the other way around, so 0, 1, 1, and so on. And to do this, let's change the for loop a little bit by saying I element in enumerate, and then we enumerate our binary encoder iterator. And remember that passing a data frame to a function is a call by reference and not by value. So we can actually change the data frame inside the function. Okay, and we can use the I and the element now by saying the data frame in our column at the row I is equal to the element, and the element is what we return here. So the transformed label, so 0 or 1, from our iterator here. And this is all we need to do. We don't have to return anything because, as I said, passing a data frame to a function is a call by reference. So this will actually change the original data frame. And now we can check if we actually did everything right. Let's print the data frame. Wait, where's the data frame? Ah, here. I already have the data frame here. So let's print the data frame before we transform it. And then we call the binary transformer function, pass the data frame, and how did I call answers? Answers is the name of the column. And then we print the data frame again to see if it changed anything. Okay, so let's run the code. And we can see yes, no, no, and so on has been transformed to 1, 0, 0, and so on. So it works. Perfect. But as I told you earlier, there's a slight bug in our code, which is caused by these 2 lines here. And we can see the bug when we run the code a couple of times. Yeah, you can see it. We have a yes encoded to a 1 in the first run, and then in the second run we have a yes encoded to a 0. So stop the video or pause the video and think about why this happens. And the answer is that sets are not ordered. Okay, so every time we transform the sequence into a set, we can have yes, no, or no, yes. We never know because sets are unordered. And to prevent this bug, we can actually say we delete this negative label because we also never use it. And we can say positive label equals positive label. And we just let the user provide the positive label. Okay, so here we need to change this to positive label, and we say, for example, yes will be the positive label. And if we rerun the code now, we can see that yes will always be 1. Yeah, yes, it works. So this will fix the bug. You have to keep this in mind. And yeah, I hope iterators are more understandable now after this exercise and you had a little bit fun. As always, leave a comment, let me know what I can improve, and consider subscribing. Thanks for watching and see you next time.